In this video, we're going to look at the graph of the cotangent function. So let's start over here at the picture that I have, and I want you to notice that each of these green lines represent the cotangent function, or one period of our cotangent function. I hope that you notice that these look similar to a cubic function, only it would be decreasing. And I also have vertical asymptotes occurring at the blue dotted lines. Now this cotangent graph looks a whole lot like our tangent graph, which would make sense. They're both reciprocals of each other. So that's good that they both look the same. So their properties are going to be similar in that the domain of our function is going to occur between our two asymptotes here. And the range would be between 0 and positive infinity again. So our possible y values would be between 0 and positive infinity. The period for the cotangent function is exactly the same as tangent in that one complete picture occurs between 0 and pi. The only difference between these two graphs is that cotangent is shifted. Notice that one complete period again is between 0 and pi, and these repeat on every interval of n pi. In other words, so here I have a vertical asymptote at pi, 2 pi, and it can continue on in that direction. Just like our tangent function, the cotangent function has no amplitude, although we will use that value when we actually graph it, just to mark up the y-axis. So let's jump into how we would actually graph this function. Since we said that the period of both tangent and cotangent is the same, it's going to be easy to find the period by just determining pi over b. The difference again occurs at those vertical asymptotes, so my equations for those asymptotes have to be different. For the cotangent function, I'm going to solve for the variable x by bx equals 0 and bx is equal to pi, plugging into these two equations here. After that, everything will be exactly the same. So let's jump into one of our examples. Here I want to graph the function 3 cotangent of 1/2 x, and I'm going to do this over 3 periods. So the first thing that I want to do is I want to determine what b is, and b is the coefficient next to the variable x. So since b is 1/2, the period, which is pi over b, or pi over 1/2, ends up being 2 pi. The second thing I want to do is I want to determine what the asymptotes are. And again, the asymptotes for cotangent are found by bx is equal to 0 and bx is equal to pi. So I'm going to replace b with 1/2 and solve for the variable x. And in this case, I find out that x is equal to both 0 and 2 pi. Now these are the vertical asymptotes that I'm going to mark on my graph, 0 and 2 pi, and then I also want to remember that the period is 2 pi. So the next thing I want to do is, let's see, do I have a phase shift? There's no phase shift in here since I'm not adding or subtracting a number inside of this variable. There's also no vertical shift since I'm not adding or subtracting a number to the function. So the only thing I want to really note right now is the fact that a in this case is equal to 3, and although I don't have an amplitude, I'm just going to use that number when I graph this function. So we'll come down here and let's mark up our x and y axis. We start by drawing our grid. I know I have a positive 3 and a negative 3 that I just want to represent. I know I have asymptotes occurring between 0 and 2 pi. And since I want to show 3 periods for this function, I'm going to move to the right of this asymptote by 2 pi, because that's how much this period was on this graph. So that would be 2 plus 2 is 4. Hello. And then moving in the negative direction, then I would go negative 2 pi. So let me go in and let me draw my vertical asymptotes so that I can keep all this straight. So I have a vertical asymptote here, here, there's one, and there's another. Now I do want to mark on this graph where my function is going to cross the x-axis. So halfway between negative 2 and 0 would be negative pi. halfway on the other side is positive pi, and halfway between 2 and 4 is just 3 pi. So in each of these places is where my cotangent function is going to cross the x-axis, and I know cotangent is going to be a decreasing function. Okay, so cotangent is going to come down, scoot across, and then continue in the negative direction. So we come down, we cross, and continue in the negative direction. One last time, down, cross, and continue in the negative direction. So you can see that the only thing that's different between, that I would say, there's two things probably, that's different between cotangent and tangent. Not only is it a decreasing function, but my vertical asymptote equations are going to be slightly different because the function is actually shifted. Everything else, as far as if I were going to do a phase shift, so if this cotangent function were shifted left or right, that's the same as what we've been doing before. And a vertical shift, where we might shift the x-axis up or down, is going to be the same as what we've done before also.